The next part of this R introduction looks at a simple linear regression example. The actual data analysis stuff should be very familiar. If it's not, then you definitely do not have the prerequisites for this course. What will be new then, of course, will be the R aspect of it. And so let's consider we have a simple data set that includes the high school and college GPA of students at a particular university. And we would like to use high school GPA to estimate college GPA in a simple linear regression model. So first of all, in how I construct my notes here, notice I have a name. Actually, I have a name for the example. And then in parentheses, I have a corresponding R program. And in this case, I have a particular data set that's an ASCII text file. This is typically how I organize introductions to examples. In this data set, then, we have high school GPA as the independent variable and college GPA denoted by this form of the variable, this name. We have college GPA as the dependent variable. And so let's take a look at my corresponding R program, gpa.r, that you can download from my corresponding course website. And so at the very beginning of the program, I just give some information using comments about what the program does, who the author is, and when it was originally written. I strongly recommend that you do something like this in all your programs. Next, what I need to do is actually read in my data set. Let me go ahead and find the ASCII text file on my computer here. Oops, wrong directory. Here we go. So it's just a plain ASCII text file to separate columns or columns of information or separate variables. Notice I just simply use a space. So for the first student, their high school GPA was 3.04 and their college GPA was 3.1, and there are a total of 20 students if you were to count all the rows of this data set. Okay, so to read in this data into R so that I can fit a regression model to this data, I can use a function called read.table. And the name comes from the fact that the data looks like it's kind of in a tabular format. And the first argument is the location on my hard drive where the data is located. Now I have this data actually located in a few different places, and one place where it's located is in my data folder, and again the file is called gpa.txt. Now notice how I specify the location on my hard drive. I use quotes around the actual physical address, and then I use a double slash here to separate the different folders that I may have, and also the file name. Now note that on the what you're probably used to seeing in Windows is just a single slash. Well, R requires 2 slashes. Now in the actual data set itself, unfortunately I closed it out. Let me take a look at it again. Notice the first row, the first row contains the actual name of the variables. And in that case, I can say header equal true so that R can pick off the variable names. And then lastly, since I'm using a space delimited file for SEP, meaning separator, I put quote quote, or I could have put quote space quote. R recognizes it to be the same thing. If I had a comma delimited file instead, meaning that, just make sure you follow this, let's say instead I had commas here, what I could have done was just simply put a comma there. We'll see shortly another way to read in a comma delimited file. So when I execute this segment of code, so I come over here to my rsend selection, it transfers the function and the corresponding arguments and argument values to R, and we see my data has been read in. The problem is, though, it hasn't been saved into an object. So that's why I say GPA then gets the results from read.table. And now if I type GPA, I see I have an object that contains my GPA data set. Now, in R's terminology, a data set that looks like this, where I have nice columns of data here, is called a data frame. You'll see that name coming up again later. If I want to access, let's say, particular variables in the data frame, there's a few different ways to do this. One way is to say GPA $HS.GPA, and then I'll get the first variable. If I do the same thing with college.GPA, I get the second variable. So the main thing to understand here then is that use a $ then to help get within a data frame to access part of it. Another way to access part of it, and this is covered at towards the end of the notes, is to specify row and column numbers. So if I say row 1, column 1, where I use square brackets and a comma to separate the row number from the column number, then I get the first observation, the high school GPA value. If instead I would say GPA bracket 1 comma end bracket, then that tells R, well, give me the whole first row. If I did a bracket comma 1 end bracket, then I get the whole first column. And in fact, I can do this a variety of different ways. Suppose I did GPA bracket 1 colon 5 comma 1 end bracket. That colon in R basically means the word to, T-O. So row 1 to 5, column 1, and there you go. And also then the first 5 observations as well. So there's a variety of different ways to access parts of a data frame. The preferred way is to use the $ format, but at times you need to be a little bit more fine, and it's helpful to be able to specify row and column numbers in a data frame. Okay, so I read in my data. You can verify with the plain ASCII text file to make sure that indeed you did read in the data correctly. One of the first things you might want to do then after that is just to summarize the data, and there's a nice handy function called summary that will allow us to summarize what's in the data frame. So I say summary parentheses GPA end parentheses, and there is mean, median, and some other summary measures. Also, one of the first things you would want to do with a data set like this is to plot the data. And so I can use the plot function to do this, where for my first argument, I'm going to use x, and I'm going to specify that I want to pull out the high school.GPA variable. And for my y-axis, I want the college GPA. And there is now a new window. This is called a graphics window that contains my data plotted. And this is the most basic kind of plot that you can do. And typically it's not going to be good enough. It's not going to be descriptive enough. It's not going to be able to take advantage of certain things to make the plot more readable to people. So let's look at ways that we can make this plot look nicer. So let me come back here to my program then. Page down a little bit. So to do a better plot, again, use the plot function, same x-axis value, same y-axis value, but I can now use an x-axis label, let's call it high school GPA, a y-axis label, we'll call it college GPA, and let's put a main title on the plot. Of course, it's good to always know, well, what's actually being plotted, college GPA versus high school GPA. Then I can also set my x-axis limits, and I'm going to combine together into a vector 0 and 4.5. The first number corresponds to the minimum value on the x-axis. The second number corresponds to the maximum value on the x-axis. The reason why I went up to 4.5 instead of 4.0 is because, of course, high school students can take advanced placement classes, so they can actually have a GPA greater than 4.0. My y-axis limits going to be a minimum of 0, maximum of 4.0. The color of the plotting points, how about red? The plotting character that's going to be used, plotting character number 1, that's going to be an open circle. You'll see shortly what other plotting characters are. CEX corresponds to, well, how big do you want the plotting characters to be, where the default is 1. If I were to do 1.5, it would be 50% greater than default. 0.5 would be 50% less than default. And then lastly, panel.first is an argument that allows me to do a number of different things, and we primarily will just use it for grid lines. It's always good to have grid lines on a plot, where the color of the grid lines is going to be simply gray. The line type for the grid lines is going to be dotted. So let me execute that code and we can see our better looking plot. And there we go. Notice the plotting points are in red. We have grid lines. Look at the x-axis and y-axis limits as well. So this takes us then to approximately page 26 in the notes. So there's a few things I want to go back and discuss. First of all, sometimes you might have, let's say, a comma delimited file. We briefly talked about one way already to read in a comma delimited file. Now, one of the nice things that you can do if you do have a comma delimited file is that you can simplify the kind of code that we saw up there previously to simply simply using the function read.csv. This function assumes that the first row of the data file contains the variable names, and you don't need to specify how it's delimited because you've already said comma delimited. And so if my comma delimited file was a gpa.csv, I just simply put it in there and I can read in my data. Note that of course I would need to specify the actual location on my hard drive where it's located. A little bit easier way to have to avoid always saying C : data / whatever folder structure you have is to set a working directory using the function setwd, specify a directory on your hard drive, and then whenever you need to access something on your hard drive, now R automatically assumes everything is now in the data folder. You don't need to specify the full extension there. Well, what about Excel files? Well, I recommend don't using Excel files. Ever since 64-bit computers came out, there's been issues not just with R, but with other statistical software packages with reading in Excel files. If you have to worry about if it's a 32-bit or 64-bit Excel file, and if you're using a 32-bit or 64-bit version of a statistical software package. But what I do here is give you an example of how to read in an Excel file using the RLDBC package. This assumes you have a 32-bit Excel on your computer and you're using 32-bit R. Okay. Let's see here. So on page 27 of the notes, let me go ahead and go there. At the bottom of the page, I give some more descriptions about the various arguments in the plot function. In particular, when we're talking about colors, we simply use red and gray. Well, all the usual color names, as you would expect, are available to you. But you can actually run simply colors at a command prompt. And you can see the 657 different color names that can be used. Also, oops, let me go back to here. Also here, someone who I think had a little bit too much time on their hands decided to actually create a chart that actually shows all the colors that are available in the order that we just saw. And in addition to just simply specifying the name of the color, you can actually specify a corresponding number. So the number 1, for example, COL equal 1 would correspond to white. COL equal 33 would correspond to red, for example. Plotting characters, that was corresponding to the PCH argument that we saw. PCH equal 1 is this open circle. That's usually a good one, a good plotting point to always use, rather than the PCH equals 16, which is a closed circle, because this could hide particular observations that may be plotted like in a scatter plot. So typically the first plotting character is good to use, but if you want to use something else for a variety of different purposes, here's a listing of 25 characters that are available to you. With respect to the line types that we saw, if you remember, we use a dotted line type for the grid lines. There's also solid, dash, dot dash, long dash, two dash. You can specify either the line name in quotes, or you can give a corresponding number as well, not in quotes. There's actually a whole lot more line types that you can create. If you're interested in how to do that, I recommend taking a look at the R graphics book. That gives some details of how to do that. Okay. Now, let's say that I want to take this plot and put it into a Word file. You often will need to do that in for projects. And the way to do that is to go into your graphics window and click on File, Copy to the Clipboard as a meta file. And then I can come over here to Word. Let me bring my window over. And there is my plot, simply put into Word. One annoying feature that Word 2012 and after has is that, notice when my graph is highlighted here, we see a whole bunch of empty space around it. This didn't happen before with earlier versions of Word. Well, and this means now you're going to have to always crop it. So like in Word, I can go under the Format tab, crop, and just simply crop it as you would any other graphic in a Word file. Okay, so please always remember to do that so we have big open spaces. Let's see, to make sure, let me look at my notes here to make sure I've copied, or I talked about everything that I wanted to. Okay, good. So, continuing then on page 29, let's actually now estimate our regression model. And to do that, there's a function called LM, standing for linear model, in R that estimates our model. First, we need to specify our actual model to R. So we say formula equal. We specify the dependent or response variable first, college.gpa. Second comes the independent variable, or explanatory variable, or covariate, sometimes people call it that, called high school GPA. To separate the dependent from the independent variable, we use a tilde. Notice we don't use this equal sign. R and some other software packages use tildes. Then to specify where the data is actually located, I say data equal my GPA data frame. So I'm going to estimate the model. I'm going to put the results into an object called mod.fit for the lack of a better name. So let's go ahead and do that. So now the model has been estimated. To see what's inside mod.fit, we can type mod.fit. And you are given some information of what's in there. So for example, the estimated intercept, often denoted by beta hat 0, is 1.08. My estimated slope, often denoted by beta hat 1, is 0.6125. So if I were to write that out, just to make sure this is clear, let me go ahead and do that. Let me get my pen out. So my estimated model is college GPA hat. Of course, I have to use a hat there because it's an estimated value. It's not the true value. And it's 1.0869 plus, unfortunately I'm running out of room here, 0.6125 times high school GPA. Okay, so there's my estimated regression model. Now, there's actually a whole bunch more information stored in mod.fit than what we had just saw in the R console. And to see a listing of all components inside mod.fit, we can use a function called names. So if I say names mod.fit, now we have a list of everything that's actually inside of there. So if I want to access parts of these items in this list, I can say mod.fit $, similar to what we saw before, coefficients. And notice I get my beta hat 0, my beta hat 1 back. I can say mod.fit $, residuals, and I get my residuals back. So to access parts of this object, I simply use the $ again, like what we did with the data frame. Now, objects such as mod.fit are referred to as lists, L-I-S-T-S, because it provides lists of information. So to help demonstrate this a little bit better, so we have this object called mod.fit. And basically, what this serves as a way to combine a whole bunch of information together, such as coefficients, such as residuals, and you saw a list of a whole bunch of other different values as well. So mod.fit just kind of joins everything together. And again, it's this kind of a format of an object is called a list. Now, remember that GPA data frame that we saw, and basically it joined together college.gpa and also high school.gpa. There's high school GPA. And basically a data frame is just a special case of a list, where the difference can be seen as in the following way. Or why it's a special case can be seen in the following way. So notice how this coefficients only has 2 elements in it. Residuals has 20 elements in it. So the items in a list in general don't necessarily have to have the exact same number of elements inside of it. Where with GPA, both college GPA and high school GPA had exactly the same number of elements. So that's why a data frame is a special case of a list. Okay, now let's get back to where we were in the notes. We are on about page 30. Okay. So another component of mod.fit is residuals. So if I wanted to print just the first 5 residuals, I can, similar to what we saw before, I can specify 1 to 5. And let's just show that. And, oftentimes we don't need all the numbers after the decimal place. So a simple way to handle that is to use the round function to make things look nice. So I say round. I'm going to round to 2 decimal places. And there we go. Now, often what one does once you have a regression model being fit is you construct a new data set that has your original data set in it, but also contains your predicted values, let's say your y hats, and your residuals too. So the way that we can do that here is to use the data frame function. So let's go down to it. There we go. So I say data frame, and then you can think of your putting everything together by column. So I'm going to put my original GPA data set there, and then I'm going to create a new variable called c.gpa.hat for college GPA estimated value. I'm going to pull out of the mod.fit list the fitted.values, which corresponds to the predicted values or y hats. I'll round it to 2 decimal places. Also in this new data frame, I'm going to put the residuals, and similar to what we saw just a few minutes ago, I'm going to find the residuals rounded to 2 decimal places. I'm going to put all these results into a new object called save.fit. This is going to be a new data frame, and this is what it looks like. So for the first observation, the observed college GPA was 3.1, but the model predicted to be 2.95. And if you were to take 3.1 minus 2.95, you get 0.15, our residual. A quick way to often see part of the elements of a data frame is to use the head function. So if I say head save.fit, if I say head save.fit, we see the first 6 observations are given. And that's the default. If I say, if I use the argument n equal 2, we can see we get we get just the first 2. There's also a corresponding tail function that shows you the end of the data frame as well. Okay, well, let's say that we want to summarize all the information that's in mod.fit, that list. Well, we can use the summary function, as you might expect. And now we have a regular old summary of the regression model. We get some standard errors. We get a test for whether or not the beta 1 is equal to 0 or not. Notice that the p-value is 0.0001, so there's sufficient evidence or strong evidence to suggest that indeed there is a linear relationship between high school and college GPA. We also have other information such as an R-squared that, of course, as you've learned in another class before, summarizes, it's a measurement of the fit of the model. We have a summary of the residuals too, so we see a summary of the information that's in mod.fit. Now you might be wondering, well, why did that summary function, which we've actually seen before, give us this kind of summary here, but before, when we said summary GPA, we got that kind of a summary? Well, this gets into one of the more advanced aspects of R. What's a more advanced aspect, it is very important to understand. And that is, there are what are called generic functions. Summary is a generic function, for example. And the way that these generic functions behave, the way that they work, depends upon what's called the class of the object that it's being used with. So if I say class GPA and class mod.fit, you can see that they have 2 different classes. So thus, when summary is used with GPA or mod.fit, it's going to have a different outcome. And in fact, what happens is that once a generic function is invoked or run, the first thing it does, it looks, well, what class is the corresponding object? And in this particular case, we'll find the class is a data.frame. So what this summary function does then, it actually sends then GPA to a new function called summary.data.frame. Also, with respect to mod.fit, when we ran summary mod.fit earlier, first thing that summary does, it looks to see what's the class of that object. Well, it's LM. So then summary sends mod.fit to a new function called summary.lm. Now, the most important reason why you need to understand that, or how R behaves with respect to generic function, is that let's say that you want to find the help corresponding to summary. And if I do that, let me bring over my window here, we get information about summary. Notice it says summary is a generic function, but it really doesn't give a whole lot of good information about how to use summary or what information is given by summary. So instead, when you're working with generic functions, look up the help corresponding to the corresponding what's called method function. So summary.lm. And now we get a little bit more information about how summary is going to behave when it's used with a object of class LM. Similar thing happens with a data.frame too. In fact, you can go to the help for, look up the help for summary, and you're going to see a whole bunch of other method functions listed with it. Okay, let's move on here. This takes us to page 33 in the notes. Oops, a little bit too far. So we've already seen the estimated regression model. Now let's do a plot of the estimated regression model with the scatter plot displayed as well. So let me get back to 10R here. I'm going to show you a few different plotting aspects to using R. It's a little bit more advanced, but we're going to be doing a lot of plotting in this course. That's why it's important to do this. So first of all, let's say that I want to open up a whole new graphics window. Maybe I want to keep what was in my previous graphics window, keep it there, and I want to open up a whole new window. One way to do that is use the win.graph function. And so the width is going to be 8 inches, height 6 inches, the font size will be 10. Oops. And there's my new graphics window. And I'm actually going to do two plots, but I'm going to put them both in the same window. And one way to do that is to use the par function. Par stands for graphics parameters. There are many different parameters, not used in a statistical sense, many different parameters that you can set that controls how your plot's going to look. In this particular case, I'm going to make a frame by row, so MF row equal 1 row, 2 columns worth of plots. Take a look at the help for par and you'll see a whole bunch of other graphics parameters that can be set. And now let's do our first plot. So I'm going to do a scatter plot just like what we did before. Let's actually just verify it's there. Yes, indeed it's there. Notice how it's only in the second column of the graphics window. I'm sorry, it's in the first column of the graphics window. And then to put then the estimated regression model on the plot, I'm going to use a function called AB line. The name AB line comes from the simple equation y is equal to a plus b times x that you learned about in your first algebra class. A is the intercept, b is the slope. So remember, mod.fit $ coefficients contains beta hat 0 and beta hat 1, the intercept, y-intercept, and the slope. So if I pull out the first element of mod.fit $ coefficients, I get beta hat 0. And that's going to be my a of y is equal to a plus b times x. I'm going to do a similar thing for the slope. I'm going to make it a solid line with a color 2. And then I'm going to use a line width of 2. The default is 1. So a value of 2 means it's going to be twice as wide in terms of the width of the line on the plot than the default. And there is my plot. Now you note that the line looks a little bit, maybe not quite straight, a little wavy. There are ways to save this plot. In particular, if I do file save as a PDF, and you will no longer see any kind of waviness there. It's just I guess it's just a distortion of the screen itself. And so here's my estimated regression model. One problem with this model is that notice it's actually extrapolating beyond the range of the data. Of course, that's a kind of a no-no to do. You shouldn't go beyond your highest x or your lowest x, which this line does. So to fix that problem, let's take a look at another way to put a line on the plot. First of all, I'm going to get a new scatter plot, put it right next to the plot that we just had. And then I'm going to use a function called curve. Curve allows you to draw straight lines, or it allows you to draw various curves as well. And basically what you need to do is write an expression for the line. So here is my y-intercept plus my slope times x. Now, no matter what you're using for the name of your independent variable, you always have to use x there, because this x then corresponds to what R is treating as the x-axis. And now I can say I want to draw my line from the minimum high school GPA to the maximum high school GPA. Color blue. I'm going to add it to the current plot, line width of 2. Let's take a look. And there we go. Now we got a better looking line. Okay. Let me just double check. We've talked about everything that I need to. Yes. So now we're on page 35 of the notes. And on page 35, I guess we can just go there. I show an actual function that I've written that basically does a lot of the stuff that we just got done doing. Meaning we estimate our model and then we plot the model. Because often that's what you want to do when you're working with a regression model. And so it would be nice if maybe we could, since we usually want to do this, it would be nice then if we wrote our own function to automatically always do that for us. And so what I have here is my own function that does it. So we saw earlier, how to write a function. This is now just a little bit more complicated version. Let me get out my pen here. So I decided to call my my function my.reg.func for the lack of a better name. So I'm going to pass in 3 bits of information. What's going to be my independent variable, my dependent variable, and the name of my data set. The first thing I'm going to do is actually estimate the model, just like what we did before, but instead of using the actual variable names that we had before, I'm going to put in there the corresponding elements that I'm going to pass into the function. I'll open up a graphics window. I'm going to plot the data. I'm going to plot the model. And notice the very last line here, mod.fit. Again, the last line in a function is what's then returned back to the users that they could save into an object. So let's take a look at using this function here. Let me get the function ready to go in R by putting the code in there. And then I'm going to use the function with my.reg.func, X variable, high school GPA, Y variable, college GPA, and my data is in GPA itself. I'm going to save the results in save.it. And there we go. So now we see my model has been plotted. Inside of save.it, we have exactly the same thing. Oops. We have exactly the same thing as what we've seen a few minutes ago. I could do a summary save.it as well. And again, we see what we've had before. So this gives you an example of how you can easily extend the default capabilities, you could say, of R to fit your own needs. So it takes us to page 37 and some final notes about using R. Okay, we already talked about the first bullet. The second bullet here is actually one of the strengths about R. Nothing's hidden to the user in terms of what actually is done for a particular statistical calculation. And if you want to see the actual code that's used to do a particular statistical calculation, all you have to do is type the function name and it's actually shown to you. Now, for new R users, even people who have used R for some time, might find all this code that you see here as very difficult to read, and that easily can be the case. However, what this though does give you is exactly what's going on, and as you become more advanced in terms of being an R user, you can figure out, okay, what does this do? What does this do? What does this do? To have a better idea of, well, how exactly does this function work? With other statistical software packages that are not open source, such as R, you don't have that ability to do. Of course, please remember to use the help if you don't understand a particular function. If you want to use mathematical expressions on a plot, such as, let's say, like a y hat or Greek letter on a plot, you can use the expression function to get it on a particular plot. And I give you an example of how to use the expression function, and here's the actual plot that I actually produced. A common question that I have from students is, well, how can I specify where the tick marks are drawn on an X or Y axis? Meaning, how can I specify maybe 0.5, 1, 1.5 versus the default of 0, 1, 2, 3, 4? Well, there's a way to do that. So for example, let's say I want to change the x-axis tick marks, their placement in the scatter plot that we've seen. First thing I can do is tell R to not draw any kind of tick marks on my x-axis by using the XAXT argument and using a value of n for no. And then to do major tick marks, meaning what you see, for example, here, the 0, 1, 2, 3, and so on, I can specify them with the access function. Side equal 1 corresponds to the usual x-axis. You can take a look at the help for what the other values of side mean. I can say, well, I want the tick marks to be drawn at a sequence of numbers starting from 0 to 4.5, and let's go by 0.5. To do minor axis tick marks, which are ones that you typically see on a plot where you maybe don't have them labeled, you have maybe smaller lines drawn between the bigger lines, you can use the access function again as I show here. Execute the code on your own to see exactly how it works. So a few minutes ago we talked about generic functions and method functions. This bullet here gives some additional information about that. One of the useful aspects of this additional bullets is that you can see a list of all methods functions by using the methods function itself. You can see a list of all generic functions by using the methods function too. Again, try this on your own to see that. Let's see here. So let's go down to this bullet here. There's a large community of R users out there. There are thousands, tens of thousands of people who are using R now. And because of that, there's a variety of different ways outside of R to get help. One way is to use the R listserv. I give a link there for that. I think for most students in our class, the best thing to use this for is you could search it for potentially answers to questions that you may have about how to use R. Another useful tool is to use Stack Overflow. There's a very large number of questions that are listed on Stack Overflow and with a number of different responses. If you've never seen Stack Overflow before, just simply go to the web link there and you'll see exactly what I mean. There are search engines dedicated to searching for R help as well. There are tons of blogs out there on R. In particular, r-bloggers.com is kind of a way to aggregate all the R blogs out there into one place. And that could be a very useful resource. Overall, my favorite blog is Revolution Analytics. It's a company that actually sells R. If you want to know more about that, come talk to me. They have a blog where they have a few posts per week that gives very useful tips about using R. Another common question I get from students is, well, are there any point-and-click ways to use R? And yes, there are. And that's through using the package called R Commander, or RCMDR. This is a package that you will need to install. Let's just briefly show how to use it. So to start R Commander, I just typed library package equal RCMDR. And this is what it looks like. If I want to get a data set ready to use R Commander, I can click on that button there. We've already read in the GPA data set before, so that's why it's available. And now what I can do is I can click on, let's do statistics. Let's see here, fit models, linear regression model. I want my response variable to be college GPA. I want my explanatory variable to be high school GPA. And let's click on OK. And look at this. We get the code similar to what we've seen before using LM function and summary function. And we get the corresponding output all listed there. So what this serves then is potentially a useful tool for learning how to use R through first some point-and-click methods so that you can learn the corresponding code. Again, this is something you can look into further, and there's a variety of different interesting drop-down menus that you can examine there to produce output. I typically do not use the R commander in class. So lastly then, on page 43, we have a kind of rough timeline for the development of R. Please take a look at that on your own. It's kind of interesting how it actually came about and where it's actually headed. So that is then the end of this introduction to R. I hope that this was useful and helpful. During the semester then we will begin again very basic with some of the material that we use or do involving R, and then we will become less basic as we go throughout the semester. So if you have any questions, please feel free to ask me.